Hello everyone. In this tutorial we discuss about 8251 peripheral chip, the internal block diagram process. So first of all, in 8251 we first discuss about the architecture. In the architecture there are some blocks are mentioned. They are read and write control logic, transmitter block, receiver block, data bus and modem control. And for read and write control logic, some points are mentioned. Student, please note down these. First of all, number 1 point is for read write control logic. The read write control logic interface the 8251 with 8285. Determine the function of the 8251 according to the control word written into its control register. Number 2 point, it monitors the data flow. Number 3 point, this section has 3 registers and they are known as control register, status register and data buffer. Now 4th point is coming out. 4th point is the active low signal read bar, write bar, CS means chip select, and C/D, D is a D bar, that is active low, are used for read write operation with these 3 registers. In the later video will be discussed about with the programming logic. Next one, when now student please note that now when this C/D, if this pin is high, the control register selected for write control word or reading the status word. Okay, please note down, when C/D is low, then 8255 take the action. What is action? The data buffer is selected for read write operation. Okay, so, and next, when reset signal of the 8251 is activate, so it is in the idle mode, and the clock input necessary for 8251 for communication with CPU, and this clock does not control either the serial transmission or the reception rate. Okay, now this is the lecture we're talking about first read and write control logic. So now we're talking about what is the transmitter part. So each block maintain their own working function. The transmitter section accept parallel data from 8085 and convert it to serial data. First point. Second point, the transmitter section is double buffered, that is it has a buffer register to hold an 8-bit parallel data and another register called output register to convert the parallel data into serial bits. Number 3, when output register is empty, the data is transferred from the buffer to the output register. Okay, now next, if buffer register is empty, then this signal TX RDY, that means transmit ready signal goes to high. Next one, if output register is empty, then this pin TX empty, this TX empty goes to high. The clock signal TXC controls the rate at which the bit are transmitted by the USART. The clock frequency can be 1, 16 or 64 times of the baud rate. Next lecture we discuss about that. Okay, so now we discuss about the receiver section. Receiver section, this is very important. The receiver section accepts serial data and convert it into parallel data. Second, the receiver section is double buffered, that is it has an input register to receive serial data and convert into parallel, and the buffer register to hold the parallel data. Okay, that's the reason. Third, when the RxD lines, RxD is a pin, RxD lines goes low, the control logic assumes it has a start bit and wait for half a bit times and sample the line again. Next one, if the line is still low, then the output register accept the following bits and form a character and load it into the buffer register. Okay, as you know, we mentioned in the previous video, in the serial communication there are 8-bit transfer, 9-bit transfer, 10-bit transfer, depending on the start bit and stop bit counting. Okay, so now we discuss about another point. The CPU reads parallel data from the buffer register. Next one, when the input register loads parallel data to buffer register, the Rx RDY, so this is very important. All students, please note down in your notebook properly, as I told by point, Rx RDY line goes high. Next point, the clock signal, the receiver clock signal RxC controls the rate at which the bit are received by the USART. And next, due to asynchronous mode, the signal, there is a signal known as SYN DET synchronous detect or break detect, BRKDET, will indicate the break in the data transmission. And during the synchronous mode, these signals, seen date and break date, will indicate the reception of synchronous character. Okay, so now we discuss about data bus, also data receiver, and modem control. Now the modem control unit allows to interface modem to 8251 first of one, and to establish the data communication through modem over like a telephone line. Okay, next one, 8251 in IO mapped in the system shown in the following figure also. And one thing should be remembered that the 825 until it takes the handshake signal from the modem interface, it cannot communicate any further characters. There have some handshake signal will be necessary for the communication purposes. So there are lots of modem control signal are allowed, and we use one IC chip. Remember, this is known as MAX 232, because this chip is basically used for to convert RS-232 level data to TTL level data. RS means recommended standard 232 signal data, which is available from the computer DB9 port, or also known as, yes right, serial port. There 9 pins are available. Each pin have their own functioning. Okay, so now we discuss about, this is the MAX 232, sorry, this is a MAX 232 basically. Okay, so MAX 232 is IC which control the RS-232 level to TTL level, or vice versa. Now we discuss about 8251 mode register. So this is very important. So all things should be remembered, because these are very important when we go the 8251 connected with 805 and using programming. So if you don't know this register concept, you cannot programming properly. So now this register is 8-bit. Okay, so bit number 7 is known as number of stop bit. So this bit number 7 and 6, these 2 bit are determine the number of stop bit. If this is 0, then this is invalid. If this is 01, then 1 stop bit. If this is 10, then 1.5 bit. And if 11, then 2 bits. So 1.5 bit also available. Now this is a bit 5. Bit 5 is for parity. If this is 0, this is what parity. If this is 1, then is even parity. Bit number 4 is parity enable. If this is 0, then parity is disable. If 1, this parity is enable. And these 2 bit are determined the total character length. Yes, if this is 00, then 5 bit. If this is 01, this is 6 bit. And if this is 10, this is 7 bit. And this is 11, this is 8 bit character. And last 2 bit, these are very important. Sorry, the last 2 bit means these 2 bits only. These 2 bits equal to 0. This is a synchronous mode. If this is 01, then clock rate is cross 1. And if then clock rate is 16 speed. And if 11, then clock rate is 64 into speed. So this is very basically the indication of speed, of the speed. Okay. Okay, now we discuss about 8251 command register. This is very important. In the command register also, this is 8-bit command register. So first we discuss about the D7 bit. So D7 bit is basically for EH. Okay, and this is known as IR. This bit is known as RTS, signal request to send. This is ER. ER means, okay, first of all we write that S break, ER, right? Then RXC. Okay, 1 2 3 4 5 6. Another 2 bits are DTR, and this is TXC. Okay, this is very important. Okay, so now one by one we study about that. So first of all, EH is known as error hunt mode. IR is known as internal reset. RTS means request to send, depending on the data buffer empty or not. Okay, ER is error reset. SBPRK, sorry, this is basically SBPRK. Okay, SBPRK means send break character. RXC means, yes, right, very good, receive enable. DTR means data terminal ready. Okay, TXC means transmit enable bit. So this bit from D7 to D0 is the status. This is known, sorry, this is known as the these are known as a command register. So due to this command we can take action on the 8251 registers. Okay, so now last one is 8251 status register. This is very important. So now what is a status register? This register is also is only show for to show the status, how the status will be of the 8251 for character transmit. So the individual bit is represented by this name FE, this is OE, this is PE, this is TXMT, TXEMPTY, and this is RX ready, and this is TX ready, RTY. Okay, so now this DSN means the dataset ready. This SYNC means synchronous character detected. FE means framing error. OE means this framing error is very important for wireless communication also. So OE is overrun error. P is a parity error. TXMT is a transmitter empty or not. RX RDY means receiver ready, and TX RDY is a transmit ready. So using this data spin, we can control the 8251 data transmission of either in synchronous or asynchronous mode transfer. So this is very important. 8251. In the later video we'll discuss about the hardware block diagram and the corresponding programming method, how to program to transfer the character using 8251 and using the serial communication method. Okay, so this is very important. So that's all for today. Thank you.